Okay, so linear inequalities. There are, what a linear inequality is it's some kind of equation that makes a line. It's in one variable, so that just means it has an x and not like an x and a y or something like that. So if this is our y-axis and this is our x-axis, our linear inequality is going to look something like this. And it's going to cut off at some point. So it's going to say, okay, we can't go less than 0 in this case. Or, if it starts like this, if it's in like on a number line like this, then it could start here and go all the way this way, but it doesn't include anything over here. So it's unequal on each side. So it's normally you're going to see less than, equal to, greater than, equal to, greater than, less than, that type of stuff. That's what we're talking about. So linear inequalities is the assignment that you guys have is a bunch of word problems. The first one is, it wants you to understand that looking at the words and saying, okay, if someone has this budget to spend on a party, so we'll say $100, and they're going to spend $48 on just an initial fee. And then per person, they spend a certain amount of money. They want you to be able to set up an equation. So if we write that out in math terms, we say, okay, you have $100 to spend on this party. And that's the most you can spend. So you have to spend less than that. So we're going to say that $100 is greater than or equal to, because you can spend $100, but you have to spend 100 or less. So if you're going to spend $100, and it costs you, we'll say $48 to set up, we're going to say $48 plus, and then this is the dependent variable is what it's called. It's where our x goes. So our dependent variable here is how many people are coming to the party. So we're going to say it cost us $5 per person. So we're multiplying how many people we have by 5 to get the number of, or the amount we will spend with each amount of people. So at 1, we will have $5 that we spend on everyone that comes. And with 48, that's just set. It's not going to change depending on how many people are coming. So if we mess with this, what we're going to do is we're going to subtract our 48 across. And what we're trying to do is just solve for x. And when we get that by itself, we know that the greatest value that x can be and still be less than 100. So here we're going to get 52. That cancels out. So now we have 5x is less than or equal to 52. So we divide by 5, and we're going to get whatever 52 divided by 5 is. 1.4?
No, 10.4.
10.4. Sorry. 10.4, so she says, is greater than or equal to x. So as long as you pick a number less than 10.4 for the number of guests that you want to have at this party, then you're good to go. You are going to stay within your $100 budget. And obviously you can't have 0.4 guests, so you're going to pick 10 people. So that will be, we're going to work it in and see how much you actually spend. So if we have $48 plus 5 times 10, 50 plus 48, and I'm just kind of using these dollar signs willy-nilly. You don't have to put them, or you can put them everywhere. It's up to you guys. We end up with $98. So that's how much we spent, which is in fact less than $100. Does this make sense to everyone? In-person people?
Yeah, we did this in like 8th grade, but I just forgot how to do.
This is probably just review for most of you. There are a couple of rules, but mostly you just treat this less than, equal to, greater than, whatever, exactly like an equal sign. There is one change to that, and we're going to go over that next. So virtual people, are y'all okay?
Yes, sir.
Okay, awesome. Okay, so I know that the numbers aren't quite the same, but I am basing this off of problem number 5. The numbers from number 1 came from number 1, and this next one is coming from number 5. The story that I'm telling is slightly different, but these numbers are very similar to those. So if you're looking for help on those types of problems, look back at these. So we're going to use the party planning example again, because again, it's the only one I can remember. So we have $500 to spend this time. We're wealthy. So we're going to say, okay, we need to spend, or we can spend $500. And we have to spend less than that. So $500 has to be greater than or equal to whatever we're going to spend. So it's going to cost us $100 for just an initial setup fee for the party planner or whatever. So I'm going to put my $100 here as a set cost. That is not going to change no matter how many people we invite. And then we're going to have $6.50 per person. So plus 6.50 times X. And I just put it in parentheses there to make it a little more explicit. So now we've set up another problem. So we work this one the exact same way. We are going to subtract 100, exactly. So this is going to give us 400 on the left side and plus 6.50x on the left side, or on the right side, I'm sorry. So now we divide by 650. And we divide by 6.50. So 400 divided by 6.5 is going to give us 61.53. So with this, we have 61.53 is less than X. So as long as we invite less than, as long as we invite less than 61 people, we're good to go on this party planning, or 61 or less. So pretty much what you're doing is when you get here, you're realizing, okay, we can't invite 0.53 of a person. So we have to round this down to 61 because we can't invite 62. So we're inviting 61. So 61 is how many people you can invite for this party. So the special rules on inequalities are, like I said, you treat them exactly like an equal sign for most of the time. But if you have like a negative sign on one side and you divide or multiply by a negative, then you have to flip the sign. So if we have negative 500 is less than or equal to negative 6.50x. So just pretend we have this in our problem. When we divide by this is going to cancel. It's going to divide just like normal. And we are going to flip our sign. That's the only difference. It's going to be the exact same way, except we flip the sign. So 500 divided by 6.5, 76.9. So those, I don't know exactly what form those problems are going to come in, but if you see some situation where you have a negative on one side and you have to get rid of it, and it's not addition or subtraction, then you remember to flip this sign because it's going to mess you up every time if you don't remember it. So is everyone okay on linear inequalities so far? You guys feel okay as to doing this assignment? Okay. Virtual people, same.
Yeah.
Okay, so what we're going to do now is move on to literal equations. A literal equation, I don't really know why they call it that. It's just treating things like constants, which just means treating things like numbers that aren't numbers. So what they have in your assignment is things like ax plus by equals c. And they say, okay, treat a, b, and c like constants. So we'll treat them like numbers. So we're just going to call them 2x plus 3y equals 4. And it wants you to solve this for x, which is just basic moving things around skills. This is Algebra 1, early Algebra 1 skills, order of operations. So I'm going to solve this one on the right, and then we're going to transition the skills to the left. They're not any different, but still. So we take, for this one on the right, we subtract our 3y over, and we can't subtract 3y from 4 because one of them has a y and one of them doesn't. So what we have to do is just write it over there by itself. 4 minus 3y. We just leave it exactly like it is. And then we divide by 2 to get our x by itself because it is multiplied, so we're canceling out multiplication by dividing. And what we do to one side, we have to do to the other every term. So when we do it to the right side, we divide by everything. And so now we get x equals 4 minus 3y over 2, which seems more complicated than it just was over here or up here, which it is, but that's what they wanted. So now we transition these skills to the left side, and we're just treating a, b, and c like constants. So now we're going to subtract our by over. So now we have ax equals c minus by. So exactly the same situation we had right here. And then we divide by a. So we end up with x equals c minus by all over a. It's the exact same situation, like we're handling it the exact same way we do with numbers. It's just there are letters there instead. So I personally think this is one of the easier sections. I think this is easier than linear inequalities, just because all it takes is the same skills and you don't have to remember to flip the sign. So one more that we're going to work is y equals mx plus b, which you are going to see again today. And they want us to solve this for x. So again, I'm going to do this with numbers. I'm going to do y equals 2x plus 3. So we're trying to get x by itself. We subtract 3 across, so minus 3. And again, we can't subtract these because it's y and 3. They don't mesh exactly. So we end up with y minus 3. This cancels out. We end up with 2x. We divide by 2 because we're undoing multiplication. This cancels. We end up with y minus 3 over 2 equals x, which is what we're looking for. When x completely by itself, we're good to go. So on the left side, we're going to use these exact same techniques. We're going to get x by itself. So minus b. This cancels. We're going to end up with y minus b over here equals mx. So now we divide by m. This will cancel. We are left with m minus b, or y minus b over m equals x. And this is the problem that your homework will have. It's the symbolic one, the one with only letters. So just be aware that that's what you're doing, is you're just treating them like numbers. Okay, we good on this? I think this is really easy. Virtual people, you still okay?
Yeah.
Okay. Compound inequalities. So this is inequalities plus and or. And or mean exactly what you think they mean. So if we have if we have 5x plus 3 is less than negative 32, or negative 4x plus 7 is less than 29. And this is bigger than what we've seen before, but it's not any different. We treat it the exact same way, and then we handle the or. So we're going to divide these in half. I'm just going to divide it right down the middle, and we're going to get back to the or in just a second. So we're going to treat them like two separate problems, and we're going to solve them for x. So we're going to subtract our 3 across, subtract our 3 across. We're getting x by itself, which is going to be a theme. So that cancels. We end up with negative 35 right here. 5x is less than. We divide by 5, divide by 5. That cancels. X is less than negative 7. Okay, so that's one part of our problem. Now we solve the right side. So we subtract 7 across. This is supposed to be negative. I apologize. This is 29. So we subtract 7. This will cancel. We'll end up with negative 36 here. Negative 4x. So this is the situation where we need to flip the sign. So we're dividing by negative 4 to get x completely by itself. And I believe that is 9 is what it's going to give us. But we also have to do this. So now we have two simplified equations on each side, and they are separated by an or. So what it wants you to do is graph this. So if we go down a little bit and we draw a number line, we need to shade in and color and all of that what we are selecting here. So we're saying x is either less than 7 or greater than 9. So I'm going to put negative 7 and 9 on our number line. Those are our important points. You can draw it out if you would like. I usually just stick to important points. And now we're saying, we're graphing each of them individually. We're saying x is less than negative 7. So we know that this is less than negative 7. I'm going to need to do this in a different color, actually. This is less than negative 7. So everything this way is definitely colored in. We can select that and it will make this true. But one thing that we need to remember when we're graphing inequalities like this is if it's like this with no line under it, no equal to, then we use an open circle. If we do have an equal to right there, we'll use a closed circle. So just keep that in mind. It is not super important, but just I remember it by saying extra mark, extra dark. I mean, some dude said that to me in middle school, and I've remembered it ever since. So now we're graphing the other one. So we're saying it has to be this or this. So on the right side, we say x is greater than 9. So we're going to use our open circle again because there's no extra mark. And we are going to color in everything that is greater than 9. So really for or, all you do is just graph the equations like they are. On the other hand, if we had an and right here, we would graph this differently. I'm going to do this in green instead, so that way we can see the difference. Okay, So we graph our number line again. And let's actually flip one of these. Let's do x is greater than -7 and x is greater than 9. So I'm still going to put my -7 and my 9 on the number line. And now we have to figure out what fits both of these conditions, because it has to be true for both of them for it to actually solve our problem. So what I like to do with these is I start by graphing them individually, and then I figure out where they overlap. That's what we're looking for. So x is greater than -7. We're going to use our open circle here, and we're going to color in everything this direction. So now x is greater than x is greater than 9 as well. So we can do an open circle here and do this. So now we're looking for overlap. So obviously our overlap is right here. This part, on the other hand, is not in our overlap. It doesn't count. It's not true for this and this. It's only true for this one. So it doesn't count. So what we do is we pretty much just erase this, and we are left with that because it's the only part that is true for both of them. Does this make sense? These pretty much, they're just graphing, and when you see and, look for overlap. When you see or, you're just graphing them each individually, and it doesn't matter if there's overlap or not. These are pretty much just linear inequalities plus graphing. Is everybody okay with linear inequalities plus graphing? These are called compound inequalities.
Can we do another one?
Absolutely. Does anybody happen to have their homework pulled up? Yeah, because we're ahead, so. Because we have 19 hours per week to meet. Okay, I will pull it up. Compound inequalities. Okay, so we will work number 1. Can somebody write this down and read it back to me? Just because I have to go away from the screen to be able to.
Yeah, what's first?
It's this part. I appreciate it. Tell me when you got it, I'll go back. Okay, so what is it?
So it's 3p
3p
4
plus 4.
less than 4.
So this way?
No, the other way. I'm sorry.
You're good.
I never remember.
Me neither.
Uh,
This way?
yeah, and equal to minus 14.
Minus 14.
And 1 minus 5p. Same sign. Minus 30.
So a way that you can remember which one is which is, I mean, the alligator eats the bigger number. So if it's facing the left, you can just say it's greater than, like you will read from left to right. So you say 3p plus 4 is greater than because it's eating that, and then -14. That's, I mean, again, that's how I remember it. And that was some dude in middle school. So let's work this one. Let's divide it in half again because it is 2 problems. So now we're going to solve our left-hand problem. We're going to subtract our 4 across, subtract our 4, negative 18 here. Still less than, because we haven't divided by a negative or multiplied by a negative. We end up with 3p. Divided by 3, divided by 3. Still no division by a negative, so our sign stays the same. So we're going to end up with negative 6. P is greater than negative 6. So we're good here. Now we need to work on the right side. So this is the same thing. We're just solving for P. I'm going to subtract my 1 across. Minus 1. So negative 40. Now we have negative 5p is less than or equal, or is greater than or equal to, divided by negative 5, divided by negative 5. So we did divide by a negative, so we're flipping our sign. We end up with, I believe that is 8. So p is less than or equal to 8. One thing about this, I am capable of skipping some of these steps and not writing them down. If you need to write them down, there's nothing wrong with that. Write it down as many times as you need it to, because that's better than getting it confused and missing the problem, especially on a test. Okay, so now we go about graphing this. So I'm going to erase my little line that divided us, and I'm going to draw my graph. I'm going to make it a little big this time. It's just a number line, so I'm going to put my important points on it. Negative 6, 8. So now I am looking to graph P is greater than negative 6. So that means it's this way. We're going to use our extra mark. So we do this, and we're graphing this way. So it's all the way because it doesn't say to stop at 8. So we're just going to graph it as far as we can. I'm going to switch colors just to make it very clear. So now we're graphing P is less than 8, less than or equal to. So for less than or equal to 8, we're going to use our extra mark again. And then we're saying, okay, P is less than. So that means it goes to the left side. So we're graphing this way now. So what we're looking for now is where do these overlap? And the answer is right here. So it starts at negative 6 and it goes to negative 8. So I'm going to redraw my graph with just the correct colored in part graphed. So negative 6, 8, extra mark, extra dark, and then color in the middle. And that would be the correct graph for this problem. Does this make sense? Does that help whoever asked?
Yes, but also I can't see the correct number line, but well, line below. Okay, thank you.
Yep. Sorry. Okay. Moving on. We are getting into slope-intercept form. Have you guys seen this before? Okay. So we're going to try to make it simple. I'm going to do my best.
It was only hard on the when you had the graphics. Maybe it's because the teacher knew.
We got it.
They made it pretty easy.
He didn't make it.
Okay. So slope-intercept form, which apparently some of you have seen before, is this. And this is a form. It's something that you're going to look for in general. Y by itself, x multiplied by something plus some number. So an example, 2x plus 3 is going to be something that you see over and over from me because I like 2 and 3. So I just use them again and again. So what we need, what information we can pull out of this is m, which is our slope, and b, which is our y-intercept. The reason these are important is because when we go to graph something, we know it's going to be a line because this is the form for a line. And we know where it's going to cross the y-axis, which, if you will recall, is the up and down axis. And we know how far it is going to go up and how far it is going to go right, which is our slope. Slope is written in the form rise over run. So a lot of times you're going to see slope as a fraction. It may be y equals 2/3 x plus 3. And this is nothing to be afraid of. This is what we're looking for. So continuing my graph. So let's try to graph y equals 2x plus 3. The first thing I'm going to do is I'm going to try to pull this information out. I'm going to write over here m equals b equals. So m is our slope. It's 2. And we're going to want our slope always in the form of a fraction. So if you will remember, any number that you have is, it's the same as that. It just means 3 divided by 1 is the same as 3, because if you divide 3 up into ones, it's going to give you 3. So I'm going to write this as a fraction of 2 over 1. So now we have our rise over our run. And our y-intercept is our 3. So 3. So our y-intercept is where it crosses this axis right here. So we count up 3 and we put a dot. And then from that dot, we use our slope to find the rest of the graph. We're going to go up 2. So I'm going to count up 1, up 2, over 1, because I went up, I rose 2, and I ran 1. So now I'm going to put a line through that point. And really all you need is 2 points, which you have, one here and one here, to make this line. It can continue as far as you want it to in this direction, and it can continue as far as you want it to in the other direction. What a lot of people like to do is they like to draw a third point on the other side. So what you do for that is you just make these negative. So you go down 2 and over 1. So you rise -2, and then you run -1. So you end up right here. And if you will see, that actually falls on the line we just drew. So it's up to you if you want to do 3 points or just 2. 2 is all you need, but 3 will probably make you feel a little more comfortable. And the reason that we can flip this slope and make it negative is because we're flipping both sides, or we're flipping both sides of this. So this is the same as this, because these negative signs are just going to cancel out, and they're going to be positive. So this is some word problems as well for your assignment. The one that I have written down is number 6, and it talks about renting a car. And it says, okay, for renting a car, it's going to cost you 75 cents for every mile. So 75 cents times your miles, how many ever that is our dependent variable. That's what we multiply by x. And it costs you $80 to just rent the car in the first place. So that's not going to change. That is our fixed cost. So now we try to graph this. And one thing you'll notice immediately is this is not a fraction, but it can be a fraction. It's 3/4 of 1. So we just rewrite it as 3/4. And I believe your calculators will do that. It depends on the type of calculator, but still. Y equals 3/4 x plus 80. And so now we're going to pull out our relevant information. We're pulling out our slope, and we're pulling out our y-intercept. So now we draw our graph. You probably already have a graph, virtual people. So I'm going to count by 20s on my y, just because I don't want to count to 80. take a couple pages. So we go up 20, 40, 60, 80, and we put a dot. And I'm just going to extend this graph just a little bit, just so I've got some room to work with. And then I'm just going to label that over here. Because if you don't label it, it just looks like you wrote like 4 up, which isn't correct. So now we're going over 3. We are rising 3 and we are running 4. So we're going to rise 1, 2, 3 and run 4. 1, 2, 3, 4. So this is our point. So I'm going to go in the negative direction as well. So what I'm going to do is I'm going to flip this sign. So now I'm going to go 1, 2, 3, 1, 2, 3, 4. So any 2 points I can use. I'm going to use this one and this one. And now we have a line. And again, notice how you could have used any 2 of these points. It passes through all 3. So you don't need 3, but you can use them. Does this make sense? Let me look at this problem or not this problem, I'm sorry, this assignment, just to be sure that I'm not missing anything. That's not it. There it is. Okay, so slope-intercept form, it just pretty much wants you to identify the graph. So it gives you x plus 3 here. And so x plus 3 is exactly the same as what we've been doing. But when you're looking for your slope, remember it's y equals mx plus b. So something multiplied by x. And the only thing that we can multiply by x and still get x is 1. So our slope is going to be 1 for this one. On this one, it's going to be 1/2, -4, -3/4, so on and so forth. For our y-intercept over here, we find it's just going to be this number added to it. And if there isn't a number added to it, there isn't one like that right here. But if there isn't a number added to it, it's just 0. So it crosses at the origin, which is 0, 0. Here's the one that I was talking about renting a car. So let x represent the number of miles driven and y represent the total cost of the car rental. And it tells you up here, there's the one-time fee of 80. You're looking for one-time things. That's going to be your y-intercept a lot of times in these word problems. And then something that is per people or per mile or something like that, that's going to be your slope usually. So that's just kind of a useful little tidbit. And right here, how much would you owe the car rental company if you drove for 40 miles? I'm not going to do that one, but I will do a similar one. So if we wanted to know how far 20 miles or how much 20 miles would cost us, all we would do is we would take this and we would plug it in. So we're plugging it in for x. Y equals 3/4 times 20 miles plus 80. So 3/4 of 20 is 15. Your calculator will tell you that. I just kind of know it off the top of my head. Plus 80 equals y. So 15 plus 80 is going to give us 95 equals y. So $95 is how much it would cost us to drive 20 miles. And I mean, if we wanted to do that with 60 or 100 or 10 billion, all we would do is switch out this number. It's going to be the same process. The difficult part of this is setting up the equation. And once you've got it set up, it's pretty easy to work on. To identify your graphs I got the wrong way. To identify these graphs, you're going to need your slope and your y-intercept. I advise you to start with your y-intercept. So for this one, we have our y-intercept is 3. So I'm looking for one of these up here with a y-intercept of 3. I know this is dark, but I don't know how to change it. So a y-intercept of 3, it looks like maybe this one. And then we're looking for a slope of 1 or 1 over 1 if we convert it into fraction form. So it should rise 1 and run 1. So this is, in fact, the one for number 1, or whatever that number is. Does that make sense? All right. Well, I'm going to let you guys go today. I mean, we've covered half of next week's work. So, I mean, just stay on it and don't get behind, because we're going to cover this stuff way faster than the online class will. Virtual people, you guys have a good day. And I will see you on Monday at the same time.
I have a question.
Yes, what's up?
Did you teach a class yesterday?
No, it was Monday.
Okay,
No.
I was looking Monday one, but I didn't know if you taught one yesterday too.
No, it was just Wednesday.
Okay, thank you.
Yep. Y'all have a good day.